Okay, so my friend, yesterday we have completed till lesson 15, which was our static routing, and today we are working on our module 16, which is our default routing. Okay, so these are the topics what we will be covering in this. That what is routing, types of routing. So these we have already completed, but here we have just some introduction because this is a different routing as compared to statics. So you already know what is routing. Routing is a process of forwarding packets from one network to another network. Routing is used to create communication between two different unreachable networks. Routing is helping you to find the best path from its routing table to reach from source to destination network. Okay, and we have came to types of, like, yesterday we talked on these types of routing, that yes, we have multiple types of routing, like we have interior gateway routing protocol, we have exterior gateway routing protocol, and we have seen some types of IGP. That if we are talking about interior gateway routing protocol, which is used inside the company or inside the domain, so those are static, default, and dynamic. So we talked on static yesterday, which was manual routing. So the all routings will be configured through administrator only. But when we are talking about default routing, so default routing is only used for internet access. In default routing, you will not have any kind of path selection process, path manipulation process. Default means everything is default, and all path will be common for all users. It's not that you can define that, okay, this path will be better for this user, like that. Dynamic we will be talking after static and default configuration. So as we know that yes, we have three types of routing: static routing, which will be configured only through administrator manually, and static routing will be only configured when you know about the destination. In default routing, yes, it has to be configured via administrator, through administrator, but default routing is only configured when the destination network is unknown. And dynamic routing we will be talking after this. Okay, so what is default routing? A default routing is a technique in which a router is configured to send all packets to the same hop device or to the same destination, and it doesn't matter whatever is belongs to the particular network. Okay, means whatever data is coming, it is directly forwarding to that destination. For example, suppose, let me take one network here. See, default routing, how we can understand about default routing. Suppose I have my router here. This is my company router, and this my company router is connected with one of my layer 2 switch in our organization, and then we have some computers here. Okay, so we took one router, and then after we'll take another router as a ISP, internet service provider. So you can change the symbol for him. Change the host names like ISP. And now ISP. Okay, so here we are taking some servers like Google server and Yahoo server. Just when you will see the scenario, after that you will understand the need of the Yahoo, and this is Google. So let's enable your port numbers so you can identify, because while configuration you need it. This is your internet service provider, and these are your host PC inside in your organization. So this is your PC1, PC2, PC3, and your PC4. Now here, see, whenever your company router is connected to ISP, so here you are using one public IP address, and that public IP address will be provided by ISP. So for example, it is like that: 0/30 subnet. Okay, and this is the ISP side. So ISP is using his own public IP address, whatever. Okay, so for what you can say, for Google, the subnet is 192.168.50.0/24, and for Yahoo the subnet is 100/24, like that. So this is different subnet, and this is different subnet. Now here inside in your organization you are using this subnet, which is 10.0 something like that /24. So let's start all these devices. And now let me explain you again. So here what I told you. So in default routing, whenever you see, this is your own organization, this is your own company, this domain, this is your company, and when your company wants to communicate to outside network, right? So yesterday we have talked about static routing, right? So in static routing, what we have seen here, that you have to configure manual routing to reach to a specific destination. So suppose if I want to reach Google, so in the R1 routing table, I'm configuring those routing table manually. Okay, so this routing table we are creating manually. But here, see, if you have limited networks like one network, two network, three network, then it's okay that you can add in your routing table manually. But in the internet side, after ISP, you can have millions of networks, right? So can you add all those millions of network in your routing table? No. But as per that, if this user wants to access internet, right? So internet, this user want to access some internet, but you don't know which type of website and which type of network this user wants to access. So you don't know the destination network where this user wants to go. Okay, whether the user wants to go to Google, whether user wants to go to Yahoo, maybe Facebook, or maybe some other websites. You don't know those websites, you don't know those networks. So what, as an administrator, you are going to configure on your router so these users can come to you and they can directly communicate to the specific destination. Okay, so in those type of conditions you have to configure default routing when you do not know the destination network. Okay, so here these are default routing is talking about. Okay, now a packet is transmitted to the device for which is configured in the default routing. Okay, means any packet with it, when it will come to your device, it will directly forward to the specific network or a specific next hop. Like suppose if this user is sending here, okay, I will check my routing table and I will directly forward to ISP. If this user is also sending me, I will check my routing table, I will forward to this one. If the user is sending data to me, I will check the routing table, I will forward that. Means I am not going to process anything, I am just forwarding it. Okay, I'm not going to do any kind of routing. Means R1 is saying that I'm not going to do any kind of routing, because whatever data will come to me, I have my next hop which is predefined, so I'm going to directly forward to that next hop. Okay, default routing is used when a network deals with a single exit point. Okay, so in that condition you have to configure default routing. Okay, it is useful when you have bulk of transmission network or packets to be transferred to the next hop. Means you are not processing a bulk data is coming to you, you are directly forwarding to that next hop. But here these two things are very important. Like suppose I this like what you can say, suppose I have this network, maybe I have some specific uh, multiple companies have uh, multiple links towards ISP. So I have, this is my different ISP which is you can say that this is a different ISP which is MTN. Okay, so I want that, okay, these all users can come and they can go to MTN, no problem. But I have some other ISPs, okay, and these users are also connected through those ISPs. So for maybe this is your ISP second, okay, and you're saying that, okay, any user will come to me, okay, for this specific destination, like gtbank.com. Okay, for GT Bank. So for GT Bank, I will forward the data to this ISP because this ISP is connected to GT Bank. But for other data, I can directly forward to MTN. But if you are coming to a specific domain, so and those domains are connected to my specific ISP. Okay, when you have multiple links, but if you have single link, so you'll follow the older traditional method. Okay, but when you have multiple links, so in that you can decide that, okay, I know this some specific destination, you can follow this path. So default routing is used when the destination is unknown, like internet. A default routing helps in reducing the size of routing table. If you will check the static routing table, so if you want to reach 10 different destinations with multiple paths, so your routing table will increase as per your path and as per your destinations. So if you want to reach 10 destinations with two paths, so your routing table will have 20 lines, 20 informations. Now if you want to reach 50 networks, right, with two paths, then you will have 100 lines or 100 information in your routing table. But in default routing table you will have only single line towards ISP, that yes, any data will come to me, I will forward to this ISP, that's it. A default route or a gateway allow traffic to be forwarded to the specific route. Okay, or to the particular network, means like it will never, like, what I want to say here, if you'll come here, let me remove this one. Like if this user is sending some data towards internet, so it will not check his destination network, that okay, you belongs to which network. It will just say that you are looking for internet access, yes, I will forward you to this network, that's it. If this one is looking for some other information, that okay, I want to go to Yahoo, it will not check the destination address, it will check that okay, any data which is coming to me, I have to forward, that's it. Okay, now routers will not share any default route informations with each other, means if I have multiple neighbors in the network, like this is also route, I have three routers, and each routers are using default routes or default routing. So whatever information this router have, it will not share with this one, and this router will not share with this one. Okay, and the default routers, they say that you have to configure like this. If you'll compare with your static routing, in a static routing we configure the specific destination network address, but here we are saying that we don't know the destination address, that's why everything is 00 for us. Advantage, it is easier to configure, all the traffics will be forwarded to a specific destination, it is more efficient, whilst if you have a single path, okay, and there is no any option to be like topology change, because you have single path, right? Now disadvantage, you can say it is more expensive in terms of CPU and bandwidth utilization, because every data is coming to me and I'm processing it. Okay, it is less secure because there is no any kind of security towards data forwarding, because whatever data is coming, this router is directly forwarding to the specific next hop. Okay, so we are going to follow this lab. Okay, so let's see how we are going to configure this. So suppose we have this network already, you can take on any path or any lab you can take. So here this is our ISP. Okay, this is the public address, this is your company router, you can say this is your company router, or you can say company network. Okay, so this area, so see this, whatever scenario we are talking, so all the scenarios for now or in future also, those all scenarios are will be divided into sections. Okay, so let me tell you the sections here. See, you have two sections in this network, you're getting here. Okay, so this section what we are talking here, okay, so this section is your own private company network. Okay, you can say here private company network, right? And this section what we are talking here, this section is your public ISP section, right? So this section is my internet service provider network. So this is the internet service provider network. So this internet service provider will be responsible for this configuration, and you will be responsible for your own link configuration and your router configuration, right? Okay, so now what we are going to do, let's start the all the routers and then take a console of the all devices. So you will see how ISP is configuring his devices, and how you will be configuring your own devices. Okay, so I'm putting my Google, and then here, okay, after that ISP, and then our own router. So these is all our PCs. So what what I'm going to do here, we will be using as a default gateway some IP address. So I'm using 192.168.10.10 as a default gateway of our network. Okay, so this IP address will be fitted to our router E0 by 0, which is our LAN network. Okay, remember, any device of your network have two sections. One is, you can say, my WAN port, and this is my LAN port. Okay, so LAN port means connecting towards my network, and WAN is connecting towards the public network. Okay, so now let's come to your PC. So first of all, you have to write IP 192.168.10.1/24, and the gateway is 10.10. Simple, and you can save it. Now come to your PC2, same thing, but here the IP will be 10.2. If you're coming to PC3, 10.3 and save. Now if you're coming to PC4, PC3, PC4, save. Okay, and if you want to verify, so IP to verify, yes, IP is there. If you're coming to PC1, save, so IP. So PC1 is 10.1, PC2 is 10.2, PC3 is 10.3, PC4 is 10.4. Fine, no problem. Now I'm coming to my own router. Okay, so here what I'm going to do, here I'll configure like conft. I have two interface. So interface E0 by 0 IP address 192.168.10.10 as per our scenario, and this is the subnet mask. No shutdown is used for enabling our ports. Okay, so we have two port on your router. So you can, if you want, you can define something that, okay, description, what you can say, this is our LAN port. Okay, exit. Okay, and now if you're coming to my E0 by 1, so interface E0/1. Okay, description, this is your WAN port, and then IP address 12.1.1.1, no shut, exit. Okay, and now if you want to save, you can save the configuration. And remember, after saving the configuration, I told you how to verify. See, so IP interface brief exclude unassigned. So you can say here that yes, these are my IP addresses on the interface and the status is up. Okay, and if you'll type here, so in interface E0 by 0, see, you'll get this. Okay, the description and the detail of that port. Okay, okay, this is used in my LAN port, and this is the IP address, the detail. This is the brief information, and this is the detailed information how you can get it. Now we are talking about ISP configuration. See, lab configuration will be same for like static routing, default routing. See, initial what you have to do, if you are talking about any type of lab, okay, so your lab sections are divided into, like, see here, lab section or practice section, you can say. So the first, what you have to do, all device connectivity. Okay, so first you have to connect all the device. After connectivity, okay, after connectivity, second is decide networks or interface, okay, or interface IP networks. Then you have to come here, configure interface IP address. Then fourth is save all the configuration, or you can say verify all the interfaces, whether the status is up or down. Okay, status is up or down. Number 5, you can say, now after that you can save the router configuration. Okay, so these are few things. So what we have done, we have connected all the devices, then we decided, okay, this network will be in our private network, this network will be in our public network, like that. Okay, then we configured all the IP addresses as per interface. Okay, so we are about to configure on ISP. Let's configure it. So on ISP we have three interface. So interface E0/1, which is connecting towards my R1 network, so I'll IP address is to 12.1.1.2, and the network is this one, no shut. And then interface E/E1/2, which is connecting to my Google IP address. I'm using here 192.168.50.50.10, no shut. And then towards Yahoo, interface is 1.3 and the IP address is 100.10. 100.10, sorry, no shut. And if you want to write the description, that okay, see, normally why we used to write descriptions, like let me write it here. Suppose you as an engineer, you configured the network, right? And some other engineer, when the other engineer will come to check your network, how he will know that these interfaces are connected for which network or for which client? Okay, so interface E0/1, you can write here description, connected to GT or something. Like, you are ISP engineer, I'm not talking about your private engineer, like how ISP engineers they do. So they like, okay, it's connected to Eco Bank. Then it will come for another one, E1/2. For it will, for this it will write, okay, connected for google.com. Then it will come for, okay, description for this one, connected for yahoo.com. Okay, and then you can exit, save the configuration. Okay, and so IP interface brief. Okay, so you can get, or if you want to get more, like less details, exclude on assigns. You're getting only those interface details. So here what we have configured, so here we have configured IP address, like here we have configured 50.10. Okay, this side and here we have configured this to this interface 100.10. So IP configuration is completed, we verified, and we check the status is okay, and we have saved it. So these all configuration is completed. Now the second phase will come, that enable routing on all the routers, or routing on routers. Now which routing? Static routing. You have second is default routing, and third one is dynamic routing. Okay. Now, so static we have already completed. Okay, today we are going to configure default. So how simply we are configuring default? See, if PC1 wants to communicate to his own network which is connected to him, okay, so you will say that, okay, ping 192.168.10.2, yes, I'm able to communicate because those IP addresses are connected to me, okay, and I belongs to the same network, okay. So PC1 belongs to the same network, so PC1 is directly communicating towards the LAN PC. Okay, no need of routing. See, we haven't configured any routing, but if PC1 wants to communicate to Google or Yahoo, okay, Google, Yahoo, let's configure the IP 192.168.50.1/24, and gateway is 192.168.50.10, 50.10, 100.10. Okay, fine, save. And here IP 192.168.100.1/24, and the gateway is 10.100 or 100.10, sorry, 100.10. Okay, fine. Now if this PC wants to communicate to Google, so 50.1, no communication. Okay, why? Because 50.1, destination host unreachable, means who is telling you destination host unreachable? My router one is telling me that yes, that the destination to whom you want to communicate is not reachable to me. And if you are coming on R1 and if you are checking why you are not reachable, so router will tell you that if you are checking with so IP router will tell you that I'm only reachable to 12 and 192.168.10.0. I'm not reachable with other networks. So for making reachability to other networks, okay, so what you have to do, you have to come to your router and you have to say that conft IP route. I want to go to those network, the destination network, but I don't know the destinations. I want to reach Yahoo, I want to reach Google, I want to reach Facebook, but I don't need it, know the destination networks. So I do not have any kind of information here. Okay, and if you're talking about, so if you do not know the network, so you don't know the subnet mask also. And if you don't know the subnet mask and network, so you have to write 00. But yes, I know my ISP. So what is my ISP address? Is this one. Simple one command. And after that, when you are checking your routing table, see, now you have default route, okay, towards ISP. So if any data will come, you will throw to ISP, okay. And now if you are checking here, so IP route, do ISP know about these networks? Yes, okay. But here, if you are coming to check if your data is coming to ISPC here, network is very important to understand. See, now PC1 is sending data to R1. R1 is saying that whatever data will come, I will forward to ISP, and ISP know about Google and Yahoo, right? So what do you think? Do this PC will now communicate to Google? See here, if it will come again, and now if typing here, see the message will come, destination like a request timeout, means you're not able to communicate to 50.1. Why? Because see, R1 know, yes, I have to forward my data to ISP. Yes, very good. ISP know about the destination to whom you want to communicate, to which you want to communicate. Okay, now, but ISP do not know about R1. See here, R1 network. Do ISP has 10.0 network? No. See here, ISP know about 12, ISP know about 50, ISP know about 100, but ISP do not know about 10 networks. So you have to, what ISP people as engineer they do, they write, okay, IP route. Okay, you say that yes, I want to reply for 10.0 network. I know him, and this is my client. Okay, and now if you'll check here, so IP route, and yes, now you know your 10.0 client, okay, as ISP engineer. So now if you're pinging here, see now your communication will work. Now whether you want to ping to Google or you want to ping to Yahoo, 100.1, yes, you're communicating. Okay, so from this side, see, normally from this side you have to configure default default route towards ISP. Okay, default routes towards ISP router. And now ISP will configure a static routes towards you, because ISP will never configure default route. Okay, because when you will work in ISP, you will see that yes, ISP never configure default routing. Okay, ISP use only static routes, EIGRP and OSPF. Okay, so now you can say here, let me move this one. Now you will say that static route towards R1 router. Okay, and who will configure this? The ISP engineer will configure this. Okay, so this will be configured by ISP engineers. Okay, and this will be configured by you, because you are fully authorized to configure your own router. Okay, so now see how smooth configuration is working. Now remember, yesterday we have talked about some advanced routing, right? So in default also you have advanced routing, but advanced routing will work when you have multiple path to reach to destination. Okay, so if you want, you can configure multiple path. Okay, so see how like this is a single link, right, towards ISP, but when you have multiple links, how it will work. Okay, so you can do here default routing lab 2, default routing lab 2. So see how it is working. So in that type of conditions, you can take 1 2 5 2 3 routers. Okay, one is one is this ISP, second is this ISP. Now you can take one Ethernet switch, and then you can pick some computers. Okay, and now you can take here also two computers as like Yahoo and Facebook server, like that. Okay, or Yahoo and Google server, you can say. So this is your two server. So let's change the server. Okay, we have changed it. Okay, so switch one. This is our layer 2 switch. And these are two ISPs. Okay, ISP1 and ISP2. So you can change the symbol for him also. Okay, so you have ISP is changed. Now you can change the host name. So R2 is your ISP1, or you can simply say this is your GAMTEL, and this is your QCell. Two ISP in your country. So this is a GAMTEL and QCell. QCell. Connectivity is you can take any type of port. Okay, but make sure that you configure the port IP address as per given networks. Okay, and now this is your PC4. Fine, here you can connect this network with E0 by 1, and here also E0 by 0. Okay, so this is not PC6. You can change the name, like for this server I want, this is your Google server 1. Okay, Google server 1, and this is your Google server 2, because Google have multiple servers. Google server 2. So IP address we are selecting now. So enable the ports E0 by 0 connecting towards R1. So this is important, okay, because if you will misconfigure the port number, so at that time you will have problem. So remember I told you that these port numbers, we don't need these port numbers. Okay, so let's remove so you can see the scenario perfectly. Okay, fine. Now we can select the network. So here I'm saying that we are using 12 this network. See why I'm recording these all labs, because while maybe when you want to do labs, okay, what I'm doing, how I'm changing these, okay, how I'm making these consoles, okay, how I'm changing the colors. So these things you will come to know, okay. Okay, so here now we are putting IP for Google. Okay, so this is our, you can say 13. Okay, and as per our older network 10.0/24, here we are putting for Google same like last one. Okay, and here we are putting 100.24. Fine, nothing is missing, it's okay, fine. Now start all the routers. After starting, same process, connectivity, IP, network decision or network, what you have selected you have to put correctly. After that, IP configuration. So start all the console of the devices. Okay, so Gamtel, ISP, QCell, then R1, PC, Google. So you have to put like that. Okay, so first of all, PC IP address. So I'll come here IP 192.168.10.1/24 and gateway is 10.10. Okay, this is completed. Now I'll come to PC2 10.2, save. PC3, now PC4. Now if I'm coming to my R1 IP configuration, R1 has now 3 interface. So I'll come here conf t interface E0 by 0 IP address 12.1.1.1 no shut, then interface E/1 IP address 13.1.1.1 no shut. Now the last one is remaining, which is E0/2, and for him IP address is 192.168.10.10. Subnet mask is this one. No shutdown, exit, exit. So IP interface brief exclude unassigned. Okay, so this is the command. So IP interface brief exclude command. Okay, and see status is up, port is up, fine. Now I'll go to my gamtel. Okay, so same here. Let me put again so you'll not get confused again. Again, your scenario or your lab is divided into two sections. One is your own section where you are fully authorized to configure whatever you like, and second section is your ISP section. Okay, so this is ISP section and this is your own section, your company section. Okay, okay, like this. So you can say this is your company, own company, company A network, and this is ISP network. Okay, internet service provider network. So internet service provider users or administrator will responsible for configuring these devices, and you will be responsible for configuring your own devices. Okay, so now we are coming to gamtel. Conf t interface e0 by 0, IP address is 12.1.1.2, 252, no shut, and then interface e0/1, IP address will be 192.168.50.10, no shut, and you have to save this one. I forget to save on R1. We save it. Now gamtel is completed. If you want to verify, so IP interface brief exclude unassigned, fine. Now come to qcell. Conf t interface e0/1, IP address is 13.1.1.2, no shut, then interface e0 by 0, IP address 192.168.100.10, and the subnet mask is this one, no shut, save, and so IP interface brief again. It's okay, fine. Now I'll come to my Google. IP is 192.168.50.1/24 and gateway is 50.10. Save. Here I'll come IP 192.168.100.1/24 and gateway is 100.10. Save. Now if I'm coming to my gamtel, okay, see now what we have to do. First of all, you have to come to a PC, and if you are trying to communicate 192.168.50.1, which is your Google One IP address, destination host unreachable. So you will come to your router because you are the engineer of your own router. So you will say, okay, no problem. Let me check my IP route. Let me check my routing table. So you check that yes, I have my routing table, but in my routing table I do not have any kind of information regarding Google servers, which is hosted on 50.0 network and 100.0 network. So for that, yes, if you are configuring default routing, so you say that no problem, I have two ISP, gamtel and qcell. I'll forward my data to them and they will be responsible for providing us connectivity. So you'll say, okay, IP route 000 network. I don't know the subnet mask, but I know my next hop router. Now you'll say that yes, I have two neighbor or next hop ISP, so you have to add the address of both. Okay, now if you're coming to GAMTEL same, you have to configure static routing towards R1. So you will say that IP route 192.168.10.0 12.1.1.1 completed. Now you come to QCell. QCell will also say that okay, let me configure routing towards you, because if you will check the routing tables, do so IP route. QCell do not know about R1, right? So you will say that okay, let me write some routing table for R1 network. Okay, fine. Now when PC1 is coming and trying to communicate, yes, PC1 is reachable now. PC1 is communicating. Let me take this now. Now what the problem will come? Now you see here. Now PC1 is reachable to Google, right? PC1 is communicating to Google, no problem. Okay. But do you know that PC1 is communicating via GAMTEL or QCell? Okay, one configuration what we can change for more authentic. We can come to GAMTEL is okay. QCell conf t interface E0 by 0 IP address 192.168.50.1 50.10.255. Shit. Fine. Now let's come to Google 2. Here instead of it's 50.1/24 50.10. Say fine. So now you can see here, you can see that you are using same IP address, even if you are now you are using same. So now my question is, if you are trying to communicate to Google from PC1, you are using which path? Through GAMTEL or through QCell? Okay, so my question was, see, if you'll check everything is correct now. Now let's take the snap again. So if you will see that if so if PC1 now if PC1 is trying to communicate, right? So the packet will come to R1. Now R1 will forward through GAMTEL or through QCell, because if you'll check the scenario here, same network, same IP. Now if you're coming here, if I'm on PC1, I'm communicating to 50.1. Yes, I'm communicating, but I'm communicating to Google 1 server or Google 2 server, because IP is same here. 50.1 here also, you can say that okay, 50.1/24, and here also we have 50.1/24. So I'm communicating to which server, whether Google 1 or Google 2, I don't know. My router is just forwarding the data, right? So this is simple network, but here if you're talking about advanced, so you will say that okay, no problem. If you're coming here and if you're typing here trace 192.168.50.1, so now you will come to know that yes, my data is going to be forwarded via GAMTEL, not via QCell. But now you will say that no problem. Right now here on GAMTEL you are using 5 Mbps connection, right? And in QCell you are using 10 Mbps connection. Okay, So at that time you want to decide that, okay, no, my primary link, I want to make primary link as a qcell, and secondary I want to make gamtel. Means all the data will be passed via qcell. If qcell is down, then my data will be passed via gamtel. So in that condition you have to configure some advanced default routing, which is known as floating default routing. Okay, so see what you have to do. First of all, what you have to do, conft, first you have to delete your older routing table. Okay, and now you have to configure new routing table. See, if you want to check, so ip route, no routes towards, okay, fine. Then you write ip route towards 13. 13 is qcell to which you want to make preferred network, so you say 10. And for qcell you say 20. Oh sorry, for qcell you said 10, and for gamtel 20. Means this, the lower route will be preferred more. Okay, and now if you're putting enter here, and now if you're checking here, show ip route, now you can see that, see here, only qcell is preferred. But if you'll check the older configuration, okay, we haven't checked any configuration. Okay, see, if you'll check older configuration, at that time you will see that you have two path. For one is qcell and second one is for gamtel. But now you have qcell only. So whenever any PC wants to communicate, okay, so that PC will now communicate via qcell instead of gamtel. Okay, so this is some like normal default routing what we have done, and then we have done advanced default routing, which is known as floating default routing. So if you will check all the labs, okay, lab is with you, commands are also written there, verification command is also written there. Okay, so follow these labs, try to complete all these labs. Okay, and we will be working, see this one, remember I told you 10 mbps link and 5 mbps link. So this also we have completed. So this advanced default routing, how it is working, this is known as floating default routing. So in that condition you can define with the administrative distance that, okay, if it is 10, 10 is the highest and 5 is the lowest. So at that time lowest will be preferred over highest one. Okay, and you know what is routing table, we have already discussed. Routing table is a map of the router through which router decide how the packets will be forwarded, to whom the packet will be forwarded, and the path, the how I can reach to destination if I'm getting any packet from source. Okay, and after this, like in our next class we will be talking about some kind of path manipulation, and we will find that, okay, if I'm using a static routes and default route, okay, so which router or which path will be preferred to reach to a specific destination. Okay, so I think we have completed the default routing, and in our next class we will be talking about this path manipulation and the lesson number 17, which is dynamic routing.